this computer. All right, let's see who's here. We got some kiddos.
Can you make it so I can?
Oh yeah, for sure. Let's see, where are we? Whoa, good grief, they're coming in fast and furious. Fast and furious. Let's see. I don't see. Where are you? Stay still. Yes. Okie dokie, Finokies. Welcome, welcome, welcome. Welcome to class. Welcome to class. Please privately answer the do now. Please privately answer the do now. Privately answer the do now. Good morning, Adrian Hernandez. Please privately answer the do now. To Dr. Smith or myself.
Either one is fine. Yeah.
Yeah. And as a matter of fact, Dr. Smith, because I need to use the restroom. I haven't been in the restroom in a couple hours. I'm going to try to jump out real quick. I'll be right back.
All right.
I'm about to pee on this.
Good morning. For those of you that are just coming in, the do now is on the screen. So you can go ahead and send your answer directly to me. Make sure you send it privately. Good morning and welcome. So the do now is on the screen. Go ahead and submit your answers privately, and you can submit those directly to me. How are you guys doing this morning? Okay, if you're having problems with your audio, just shoot us a message, and I do have one that's coming through right now, and you can go ahead and turn your screen on and see it off and see if that helps. So if you are having challenges with your audio or some other type of technical issue, you are welcome to go ahead and turn your screen off. Just shoot me a message or Mr. Pope a message so we know who you are and we can make a note of that.
That's our visitor.
Yes. Okay. Hi, how are you? Let's see, how do I do that?
We only have 11 people here so far, huh? Oh, I lost audio. Can you hear me?
Yes, I can hear you. Can you hear me okay now?
Yeah. I couldn't hear you. Okay, dope.
So I do have a few responses coming through on this end.
Awesome. I think a lot of the students must be having a tough time leaving their last class. They got held.
Oh, okay.
I guess there's very few. We only have 11 students thus far.
Let's see. We still have 2 minutes before class time. So
yeah.
they're making their way.
So if you just joined us, please send us a text privately. Please privately send us a text saying that, you know, the answer. So is it A, B, C, or D? One of you guys will be held accountable, like in terms of we're going to ask you, why is it that you chose that? But in the meantime, please put your answers in the chat box and send them to Dr. Smith and I. Kind of like to see a consensus of answers. Yes, please keep it private, not in the open. Thank you.
And Mr. Pop, I just sent you the ones that I had on my end.
Oh,
so
thank you,
can
thank you, thank
tally
you.
them on. Yeah.
Oh, okay, yeah. So far we have, it looks like 6 of you guys have sent an answer. Some of you guys just joined us. So if you're just joining us, you should be sending us your response for the do now. Please send your response to the do now. Excellent, excellent. So that's 8. That's 8 of you guys thus far. Wow, you just got in the room and sent an answer that quick. It's kind of scary. Take your time, kid. Whether it's right or wrong, I'd take a little time. So we'll take an answer from you guys at 11:01. Everybody should have their answers in. So far we have, looks like 10, and there should be 14 answers. Thank you, thank you, thank you. There's 13. We just had an 8. We are at 8:16. So we need 5 more answers. We need 5 more answers. Class has now officially started. It is 11 o'clock on this Thursday morning. Fine Thursday morning it is too. So it's really nice to see you guys. The do now is up. So you guys that have just joined us, the do now is here on the screen. Please submit your answers. We're waiting for everybody to submit their answer. Also, as a reminder, if you are obscured and we cannot see you, then that means that you need to turn on your camera unless there's a reason and you have cleared that with Dr. Smith or myself. One of the 2 of us needs to have cleared it. You are guaranteed to be called on today if your camera is off. Not that that's a bad thing, but we just want to make sure that you're with us. Some of you guys know that I wasn't kidding when I said I'd call home if you did not have it on and we're unable to respond. So make sure that you do have your cameras on. It is 11:01. It looks like we've got them all. So let's, yeah, I think that we have all but one. So I'm going to jump over here to, let me go to who was it? DeLeon. Zanette. No, I don't want to talk to Zanette. I talked to her last time. I'm tired of listening to that tired old voice. Let's talk to Elliot James. Elliot James, man. Can you come on? Can you come on? Take your mic on, yo. I need to hear you. Whoa. I take that back. Elliot, don't turn your camera off, man. That's probably better.
Oh, okay.
Okay, that's better. Woo. Tell us, what did you choose and why?
All right. I chose A because I knew that the meat, because from the word permeable, I could tell like based on my knowledge of the word that it basically means that something can go in or out or something.
All right, can you kill your microphone?
So I chose A because that would make for like anything to pass through the cell membrane.
Okay, kill your mic. Thank you. So you said a key word there. You said Something can go through the membrane. Something. I'm gonna let those words catch up to you because I know there's a delay. But A says anything. Anything. So in this case, anything includes an elephant. So can an elephant pass through a healthy membrane? I don't know about that. So I'm not sure. I'm looking. Oh, I know. I see you guys. I see you guys. There's a lot of you guys that are throwing some answers in here. And it is B. Most of you guys put B. There is a key word in this answer choice here that tells you that B is the correct answer. You guys drop it in the chat. Drop it in the chat. What is the key word in B? What is the key word in B? There's a key word. Boom, boom. There's two. There's two. Oh man, thanks a lot, Zanette. You put it out for the world to see. Everyone can see it. Yeah, it's some things. So in this case, when we think about selectively permeable, we're talking about some things can come through, not all things. So some substances can pass through it, but not all. Perhaps we need a little demonstration. Let's see. So bear with me for a moment. Get back to share my screen. Hold on a second. Hold on a second, man. I saw Bertavion. You're on your phone in bed. Think about this, yo. Get out of bed. What's wrong with you on your phone in bed? What grade are you in? Are you 14 or are you 4? I mean, come on. Let's act like students, man. Let me get to my wonderful screen. It's going to take me a second to adjust screens, man. You got to bear with me. Bear with me. Man, what a day. Whew. So we said selectively permeable, right? So selectively means that some things can come through, some things can't. So check this out, James. Watch out, James. Watch this. Protein channel. Protein channel. Now, watch. I'm going to model diffusion. Boom, 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 boom. I'm going to drop some, well, at least I thought I was. What in the heck is going on? There we go. So it looks like those protein channels work for those little green balls, right? They're able to diffuse through just fine. Just fine. Let's reset this. And let's see if we can change something. Actually, I don't need to reset this. Let's throw another channel in here. And let's see, actually I do want to reset it. Let me reset of it completely. Reset it all. And let's see if if these blue ones can get through those. So the green can, but can the blue get through those little channels? I'll even throw another one in there. Let's make it even easier for them to get to it. There's another one. Uh-oh, they can't get through. They're unable to get through. But if I throw these green ones in here, oh, they can get through. So some things can go through a selectively permeable membrane. Some things, and that is the key term here. Selective means that some molecules are selected to pass through while others are unable to pass through, and that's going to be the key point. Both of these molecules are moving around randomly. They're definitely moving around without any kind of issue, but only some of them are able to get through while others cannot. So we're going to stop it real quick and let's go. Looks like we got a question in the chat box, or maybe not. Somebody decided not to. No, nothing new, nothing new. Okay. So I'll stop sharing and we're going to go back to where our do now was. And now we're going to apply some new terms today. We got some new terms. We're going to look at this term of tonicity. And you have to pay special close attention to what we're about to explain. So tonicity is going to determine concentrations, like how much you have of a solute or a solvent in it. Now, before we do it, just a review, diffusion is simple. It's going from a high concentration to a low concentration. So on this side of the membrane, I have a high concentration of a particle. It's any particle because it's diffusion, and it's going to move over here. So it can apparently it is going to be this membrane is permeable to whatever this is. So little purple or blue dots, they're going to pass through, and they reach an equal concentration, high to low, and then you reach an equal concentration. Then they continue to bounce back and forth. They're still moving, but they're at equal concentrations. Osmosis is a little different. It's only water. So in this water, I have dissolved maybe salt or something, sugar, salt, some kind of solute. This is a solute. Low solutes on this side, I got 1, 2, 3, 4. On this side, in the same volume, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 4 versus 14. So a lot of solutes over here, but less water. There's going to be water, higher concentration of water over here, higher percentage of water over here. So water pushes up, even so much as it fights gravity. It actually pushes upward, and there's gravity equal on both sides, but man, water has to reach equal concentration. You can see all these solutes are spaced out evenly here. They're even here and even here. Over here, the solutes are very bunched up. So that's kind of leads into what we're talking about here in terms of our what we call hypertonicity, hypotonicity, or isotonicity. So to make it a little easier, I've got little faces here on these cells. So this cell looks really upset. This one looks really kind of upset too, but in a different way. And this one's pretty pleased with himself or herself or whatever this thing is. I don't even know if cells can have genders at all. But we've got hypertonicity situation. So hypertonicity, you've got a lot of solutes. In this case, a lot of salt outside of the cell, a lot of water inside of the cell. So in this hypertonicity environment, you've got a lot of solutes. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 particles of salt or molecules of salt. And I have, whoa, get ahead of myself. And then I've got 1, 2, 3, 4, 5, 6, 7, 8 particles of water or molecules of water. So I've got, for every 1 molecule of water, there's 2 molecules of salt. That's a lot. I have a 10-year-old daughter. She's young. She's kind of hyper. She's got a lot of energy. In this case, we're talking about a lot of solutes. So that's hypertonicity. So what does water want to do? It wants to go from an area of high concentration to low concentration. So you'll notice there's arrows coming out. 1, 2, 3, 4 arrows coming out, and only 1 arrow going in. So the net movement is outward, not inward. There's some movement inward, but most of it is going to be moving outward. Hypotonicity, the exact opposite. There's a lot of salt in the cell or a lot of solutes in the cell, and there's very little solutes out. So again, there's more water outside of the cell than is in the cell. So the cell is going to pull in water. Water is going to go from a high concentration outside of the cell to inside the cell. So that explains why this guy's so big, right? It's full of water, it probably hurts. This one lost a lot of water, pretty aggravated with it. Looks like a raisin. And that's exactly what happens to raisins. You take grapes, you put them outside in the sun, the water goes into the atmosphere, and all you got is just a little bit of that fruit left without the water, and it's kind of miserable. It's kind of sad. Doesn't have any water, shrivels up. Now, isotonic is different. It's where it's equal. So I got approximately the same amount of water on the inside as the outside. The same amount of solutes is on the outside as the inside. So water goes in and out at an equal concentration or equal rate. Water's passing in and out of it equally. And it's not a big problem. Let's take a look at this another slightly different way, and let's see how that works. So excuse me for a moment. We'll come back to this. See how you guys do here. All right, let's get this thing reset. I'm going to refresh this. Last class, maybe I'm going to refresh it. My computer is slow as Christmas Eve today. Ouch, I stabbed myself. That duck is ridiculous. I hope you don't have headphones on there. I'll hurt my ears. Okay, doke. So let's see if I can get this where you guys can see it. You're thinking, what is Mr. Pope looking at? This is crazy. All right, here we are. So here I have 3 different solutions. And I don't expect you Oz all to get this correct. Nobody's expecting perfection yet. I just expect you to take a risk because we got to be a risk taker if we're ever going to get anywhere. Confusion is the first step to understanding. So I have 3 different cells. So this is a blood cell from my finger. That's where the ouch came from. Then I've got a Lodia cell. And a Lodia cell is a plant. So, or it's a cell from a plant. There's a plant called a Lodia. If you're in class, I actually have some right here in this classroom. And then we have paramecium, and that's just this protist that lives here in the water. Now I'm going to take these cells. Actually, I'm not. You are. You're going to tell us which one you want it, where to go. So red blood cell, and you can choose in a moment. You can say, I want to choose a red blood cell, and you can put it in a hypotonic, isotonic, or hypertonic. And when we call on you, all you have to tell us is the cell going to get smaller? Is it going to get larger? Or is it going to stay the same? I don't expect you to tell us why yet. I just want you to tell us smaller, larger, or stay the same. And let's see who the first contestant is going to be. It's going to be Jasmine Williams. Jasmine Williams. Yay, Jasmine. So Jasmine, you choose red blood cell, a Lodia cell, or paramecium. And guys, please don't say what it's going to be in the chat box yet. Let her be on the hook. Let her be on the hook. Okay. Okay. Please do that.
I say red blood cell is gonna get bigger.
Which one? You got to put it in a solution. Which solution you got to put it in to make it bigger? Which? Okay. That's a. Which one?
The hypotonic solution.
Hypo or hyper?
Hypo.
Okay. Let's see what happens. Look at the big brain on Williams. Ooh, you're right. I'll tell you what, you did that so quick and easy. Could you tell me why as well?
Because it takes in a lot of water, and it
Why
makes.
Why does it take in a lot of water?
Because that's what it does.
Yeah,
And
well, why does it do that?
Because whenever you drink water, it's good for your blood.
Okay, but why is it good for your blood? I don't know that that's good for my blood cell. If my blood cell, it looks like it's about to swell up and explode.
Because that's what the solution does.
Well, is it good for your cell to swell up like a balloon?
No,
Okay,
it's
all right. Why does it swell though? Do you have a reason why it got larger?
No.
Okay, that's fine. And I didn't expect that much. It's just that you did it so fast that I was thinking, man, okay, well, how about that? All right, so let's go over to Brasino. Sabina. You hear me, Sabina? Okay, kid, kill your camera and we'll be able to hear you easier. Kill your camera. Thank you. You choose a cell, Elodia or paramecium, and tell us where to put it. Okay, and you want to put it in the isotonic or hypertonic? Put it in the chat. Okay, you got ISO. Okay, tell me, smaller, larger, or stays the same? What's the cell going to do? Let's see. Oh, you're right. And check this out. Look at those arrows going both in and out. That means the water is at an equal concentration. Holy smoke. Look at the big brain on Brasinho. I love it. So last but not least, let's go to the most, Giselle Ramirez. Giselle. Whew. Giselle, what about this paramecium, yo? Where do you want to put it? In the hypertonic, hypotonic, or isotonic solution? You decide. And then you tell me, is it going to get bigger, smaller, or stay the same? You choose. You're muted. Somebody's got their mic on. Hey, Giselle. There you are. You hear me. Paramecium. Tell me where to put it. Which of these solutions? And then I want you to tell me when I put it in there, is it the cell going to get bigger, smaller, or stay the same? Giselle, I don't know. Can you give me a thumbs up if you can hear me? I don't think she can hear what I'm saying. Okay, doke. Let's go to the next. Who can? I just want to just real quick with a show of weird hands. Let's see. Mario, you're here. Yeah, I know. I saw you get kicked out earlier. So Mario, help me out really quick. With the paramecium, do I put it in hypo or hypertonic? Or no, or you have a third choice, isotonic. You tell me where you want me to put it.
Hyper.
Okay, now I'm going to put it in here. Now you tell me, is it going to get bigger or smaller or stay the same?
Maybe get bigger.
It'll get bigger in the hypertonic solution. Okay, let's see. Oh, it got smaller. Now, don't worry about it. We haven't practiced this yet. I just want you guys to be thinking about it before we start to really practice it, and then we'll practice it even more. So again, just to review these terms and what they mean. If I'm hypertonic, I've got a lot of salt or a lot of solute, something in the water, there's a lot of it dissolved around me. So there's a lower concentration of water outside of the cell than in it. So this would be like getting in salt water. If you drink salt water, your cells are going to shrink because all that water is going to leave your cells to try to balance out that concentration outside of your cells. Hypotonic is when you're drinking pure water, which will really cause a problem. All the water will try to rush into your cells, and it'll actually kill you. Believe it or not, it will. And then isotonic is where there's equal concentrations of water. So let's practice this a little more thoughtfully. So I'll do the first one, and then you guys are going to do these others. So the first one's going to be pretty simple. So I've got this cell. It's 0.9% salt, 0.9% sodium chloride, and this solution is 3% sodium chloride. So if this is going to be 0.9% sodium chloride or salt, then I have to think about how much of it's water. So let me see. I'm going to do a little math and figure that out. So if it's 0.9, that's almost 1%. It's less than 1%. So it's almost almost 1%. That's 99.1% water. If this is not 3% salt, then how much of this is water? In the chat, if this is 3% salt, how much of it's water? Drop it in the chat, yo. I need some numbers. Drop them in the chat. If this is 3% salt, what percentage of it is water? Now you got it. Keep it coming. Keep it coming. Good. I got two of you. If it's 3% salt, how much of it is water? Keep it coming. Keep it coming. There's 3 answers. There's 3. Do it privately. Wait till I get at least 10. 4. What plus 3 equals 100? There's 5. Keep it coming. What plus 3 equals 100? Keep it coming. There's 5. What plus, there's 6. What plus 3 equals 100? There's 7. Got to have at least 2 more. What plus 3 equals 100? There's 8. 1 more. Excellent. You did. It's redemption time, Elliot. You got it. 97. So 97 is less than 99. So I'm going to predict that the cell is going to, in this case, is going to get smaller. If 99 is greater than 97, so let's just do a little math and see. You guys were right. 97% water, 99% water, 99 is greater than 97. So if I put that cell in there, water's going to leave. Water's going to leave. There was other key piece of information, and always remember in your instructions, important information, cell is not permeable to salt, not permeable to salt. So the water's going to leave. The salt's going to stay in the same place. The cell's going to shrink. So let's try another one. I'm going to get past this explanation. I don't think I have time for that today. Another one of you guys is going to take this one. So I will give you guys 1 minute to think about it. And the thing that you've got to think about here is this. First, it's telling me the salt cannot pass through the membrane. You got to think about, if this is 60% salt, what percent of it is water? If this is 10% salt, what percentage of it is water? You got 1 minute, and I'll come to one of you guys in 1 minute. I'd be sharing this with my friends, yo. I'd be like, hey, buddy, I think it's this. I think it's this. Giselle, I dropped you a chat. Okay, let's go to, let's see. Zach, I haven't heard from you in a couple of days. Poor guy. He's like, oh man, not me. Please, not me. Not me. Okay, Zach. So what's going to happen to this cell, dude? Is it going to get larger or smaller? But before you answer that, just kind of give me, what percentage of this cell is water?
60?
It's 60% water, this cell?
No.
Oh, you scared me.
40?
40%. Okay, that makes a little more sense. 60 plus 40 is 100. That, okay, we're cooking with Crisco now. What about this this solution here?
90.
All right, so what's going to happen to the cell? Is it going to get smaller or larger?
Smaller.
All right, why?
Because, wait, hold on.
Whoa, hold on. Let's think about this for a second. Let's think about this.
Man, I don't even know.
Well, time to start thinking about it. That's for sure. You've got a quiz in 22 minutes.
I think it's gonna get smaller
Why? Now we got to get to the why.
because there's more water. No.
Maybe you need to see the math. Hold on a second. Let's take a look at this. You said it. Maybe you need to see it.
See.
Remember, water goes from a high to a low. So I've got 40% water versus 90% water. I see you guys chatting to me where it's what's going to happen to the cell. I see that. I'm talking to Zach. I'm talking to Zach. What's greater, 90 or 40?
D.
Would you, 90 is?
Yeah.
Okay, so if water goes from high to low, so is it going to go from the solution to the cell to the solution?
From the solution to the cell,
So if the cell's gaining water, will it get larger or will it get smaller?
it'll get larger.
I feel like we might be cooking with Crisco again. Let's see. Oh, yes, it is. If I have a greater concentration of water, the cell is going to get bigger. All right, this is a hypotonic solution. So let's try another example. And one of you guys will go. I think we'll shoot over here to, I know who it's going to be. 1 minute to think about it, though. You got 1 minute. $30. This time it'll be a person with the camera off, so I know that you can hear me. Oh, even if you just turn your camera on too late, it doesn't matter. I mean, so it's gonna be, and those with the cameras off, just go ahead. You can ask the people from last class. I've made lots of phone calls yesterday. I'll be calling some more this afternoon. So it's Kenneth. Kenneth, help me out, yo. I need to know what's gonna happen to this cell. What's gonna happen here? Is this cell gonna get larger, smaller, or stay the same? Kenneth, hi. You're the person that has been called upon. Kenneth, hi. Thank you. Let's see what you say. Nope, that's not, you're not Kenneth. Kenneth is on the hook. Okie doke. Okie doke. All right, so we'll be moving on to Bertavion Graves. Bertavion, smaller, larger? I'm sorry?
Larger.
Why? This is, so when you take a look at this cell, how much of this is water and how much of this is water? If this is 0.9% salt and this is 0.9% salt, how much of it is water? I know you have your phone there. Do me a favor. Take 100 on your phone on the calculator, 100 minus 0.9. Tell me what number you get.
99 on 1.
99.1, cool. So if the cell is 99.1% water and the solution is 99.1% water, what's going to happen? Is it going to get larger, smaller, or stay the same?
Smaller?
I'm sorry?
It should be bigger, right?
You're asking me. I'm asking you, dude. You're the one who had your camera off. You've got equal concentrations. Water goes from a high to a low. Is it already equal?
Oh, yes.
Okay, so will the cell stay the same, get larger or smaller?
Stay the same.
Sounds like it. Sounds like it to me. And I want you to, gone are the days where we can guess our way through these. You have to actually think your way through it. It's isotonic. The cell's going to stay the same. Water's going to go in and out, and so is the salt. The instructions said that the salt, it was permeable to salt. So we got to read for this. Tell you, before we take the quiz, let's practice a few questions. I'm going to show you a method for answering questions. I think you guys may need to be taught a formal method for how to answer questions. So there's a method that you can use, and this is a way that I teach my juniors, and and I'll teach freshmen now, but I mean, I've used this for freshmen. I taught freshmen as well, is you make a T-chart and you put a list of knowns and unknowns. And I'm going to do the first one. I'm going to try to back up to an easy question first. So the unknown is always what's being asked of you. So when I look at this on my T-chart, and in a moment when you take the quiz, I recommend you guys getting a piece of paper and making a T-chart and answering these questions with the time that's given, not to rush through it. So let's see. What is asking true for osmosis? So my known or my unknown is they're asking me, the question is true of osmosis. So what is true? So my knowns are the facts. So in the chat, you guys drop me at least 4 facts about osmosis. 4 facts in the chat. I need to have at least 4 facts. So I'm going to drop it in the chat real quick. You guys tell me, what are some things about osmosis that we know about osmosis? What are some things that we know about osmosis? What do we know about osmosis? Drop it in the chat. Excellent. We're getting some. Cool, thank you. Thank you. We're getting some, you guys are saying water passes through, water moves from a high to a low. I like that one. Water from high to low, so let's put that in here. Water moves from high to low. Let's see what else you guys are saying. No energy, thank you. No energy used. Let's see what else. Type of diffusion, thank you. Type of diffusion. What else can you give me? Need 4, we want 4 facts, 4 things about this. It can depend on temperature, you're right. Water is moving from the cell, that's right. It can, Yep, rate depends on, that's true. I'll put that in there. Rate depends, depends on temp. It can sometimes. That's enough. That's still 4. So let's take a look at our answer choices. See what our knowns are. So our knowns, that's 10 minutes till the quiz. So I have water moves from high to low, no energy, type of diffusion, rate depends on temp. So which of these is supported? Drop it in the chat. I need to have, in this case, I should have 20 answers. Let's go. Got one. Keep it up. Keep it up. There's one. Keep it up. What is the answer choice? What is the choice? There's 2, there's 3, there's 4. There's 5, 6, 7. Keep it up. Keep it up. There's 10. There's 10. Got to have at least 20 or we're going to get stuck. The fewer of you guys answer, the fewer questions we get to practice before the quiz. $12. We got 12. Keep it up. Keep it up. $14. Still need 6 more of you guys. Six of you guys are holding up your class. 17. 3 of you guys are holding up the class. You guys should be putting pressure on them. We need you to do this so we can practice more questions. We only have an hour, not a lot of time. 18, 2 more. 19, 1 more. Okay, so let's take a look. That's it. So, and I look at this, and I had, out of the all the answers, there were 16 people that said osmosis is a type of passive transport. Well, yeah, passive transport does not use energy. A couldn't be correct. Osmosis is the movement of oxygen. Well, that's not it. It's a water. So we can't, A wouldn't be correct. B, osmosis requires the use of energy. Well, it can't be B because it says no energy. Passive transport does not use energy. So C would be correct. D isn't correct because it says against the gradient. So that would be going from low to high. Good job. That was right. So let's try another one. So let's see, what is my unknown? Which of the following statements about passive transport is true? So true for passive transport. Drop me some facts. What are our knowns? What do we know about passive transport? Drop them, drop them, drop them. Let's see. Yes, does not use energy. Does not use energy. 3 types. That's right. 3 types. Oop, hold on a second. 3 types. And those are facilitated diffusion. Diffusion. That's a good one. And osmosis. What else you guys have? Okay. That's passes through membrane. Okay, passes through membrane. What passes through membrane? Particles, okay, particles. Let's see. Lots and lots of answers. Passes through membrane, three types. You know, it goes from high to low. I was waiting for somebody to tell me that. So high to low goes from high to low concentrations. And that is 4. So let's take a look and see what you guys have. We're looking for true. So what agrees with this? Drop it in the chat. A, B, C, or D. Let's see. A, B, C, or D. A, B, C, or D. We got 2 answers. 2, 3. Good job. You guys are going faster. 3, 4. Got to get to 20. 5, 6, 7. Stuck at 7. 8, 9. Still stuck at 9. Need 11 more answers. I'd like to practice one more before we go, before we let you take the quiz. So let's make moves. 10. Now we need 11, 12. Awesome. Now you got it. 8. We need 8 more. We need 8 more. 7 more. 6 more. 6 more. One of you guys just hit me on remind. So let's see. Still 5 more. Need 5 more answers before we can go. 4. 4 more. 3 more. Still waiting on 3 students. 2 students. 2 of you guys are holding us. Still waiting on 2 of you. I won't leave until we get an answer. You guys are, don't make me call you out. 1 more. 1 more. Let's see who that one person is that has not responded. Okay. All right, and you guys, most of you guys were saying in here that substances move from areas of high to low concentration. You're right, C would be it. Substances move from areas of high concentration to low. Got it. We've got time for 1 more. So this one's a little tougher. So let's take a look. A plant cell has 5% concentration of salt. So if it's 5% salt, how much of it is water? I need 10 responses before I'll put that. That's my known. That's my known. I need to put that. How much water? If it's 95, if it's, oh, I just answered. Shoot. Yep, that's what, yeah. I see, yeah, I got it. Awesome, okay. I screwed that up, I even said it, shoot. So yeah, so the cell is 95% water. Sorry, I screwed that up. So help me out on the solution. So the solution is 12% salt. What percentage of it is water? So that'll, and I won't say that one this time, sorry. Drop it in the chat. 1, 2, 3. Got to get at least 10. Got to get at least 10. Got to get at least 10. I want to practice this one. 6. We got 4 more. Need 4 more. 4 more. 4 more. 4 more. Still waiting for 4 people. 2 more. 2 more. 1 more. 1 more. 1 more. Yes, there you go. You guys are right. Most of you guys were correct. Some of you guys are just trying to tell me what the answer is. But I was really shooting for that, what is the solution? And most of you guys got that. So solution is 88%. So which is higher? So the question is asking if if it is placed in a solution concentration of salt. So what's going to happen? What will happen to the cell? So if the solution is 88% salt, more water in the cell than out of the cell, most of you guys were saying that yes, C. Water will move out of the plant. 95 is greater than 88, high to low. And therefore, that's what you would get. It would cause it to shrivel or go through plasmolysis. All right, so we're going to begin the quiz. Go to Schoology and go to today, Unit 1 and 924, and go to 924. I haven't opened the quiz yet. You need to get there quick, fast, in a hurry. Go to today's date, which is Unit 1, and you're looking for 924. I will open the quiz in about 2 minutes. Give everybody time to get there. Unit 1, 924. All right, you need to refresh your page, and you should be able to take the quiz. The quiz is open. You will have 8 minutes. 8 minutes. Eight minutes. You should be looking for this quiz, diffusion and osmosis quiz. You have 8 minutes. No, you cannot come back and take it this afternoon. You need to take it now. You have to take it in class first. It will not be open after this class. For those of you guys saying, is it open note? There's no way that I would know, so I couldn't stop you if I tried.
How much time do we have left?
It counts down for you. You should have a timer.